This is the Tool 19545 Leakdown tester. If possible, run the engine for 5 minutes to warm it up to operating temperature. Remove the spark plug. Remove the air filter and disconnect the crankcase breather tube from the air cleaner base if so equipped. Rotate the crankshaft in the direction of normal rotation until the piston is at top dead center with both valves closed. Install the clamp on the crankshaft and attach a breaker bar to the square hole in the clamp. This will allow you to hold the piston at top dead center as air is applied. Insert the threaded extension into the spark plug hole and hand tighten. Make sure the O-ring is seated against the head. Close the tester outlet ball valve. Pull the regulator knob out and turn the adjustment knob counterclockwise as far as it will go. Connect your shop air supply to the tester inlet fitting. Do not use high-pressure air supplies greater than 150 psi. Connect the extension from the spark plug hole to the tester. Adjust the regulator with the knob so the tester needle points to the set position. Push the regulator knob in to lock it. Firmly grasp the breaker bar to prevent air pressure from moving the piston off top dead center and slowly open the ball valve. Note the needle position on the tester dial. If the needle is firmly in the green on the dial and air loss is minimal past the compression components, the engine may be considered as healthy. If the needle on the dial is at the low end of the green or in the yellow or red, listen carefully at the air intake, muffler outlet, around the head gasket sealing area, at the breather tube, and at the open dipstick tube for air passing by these areas. Pay attention to those areas where the air loss appears to be excessive or loudest. If loudest at the air intake, inspect the intake valve. If more noise is coming from the dipstick tube, check the rings and cylinder bore and on from there. When the test is complete, close the ball outlet valve, unlock the regulator knob, and turn it counterclockwise as far as it will go to release pressure in the cylinder. Disconnect the outlet hose from the tester before removing it from the spark plug hole. That's it. This tool applies pressurized air to the sealed combustion chamber and gauges how effectively the compression components seal the chamber against the air pressure. Here's how it works. A shop airline at a minimum pressure of 70 psi and a maximum pressure of 150 psi is attached to the inlet fitting. This simulates the pressure developed in the cylinder during the power stroke. The process of adjusting the regulator to the set point calibrates the tool so that a constant known pressure is applied to the combustion chamber. The body of the tool contains a metering orifice that provides a known restriction to the airflow to the engine. A pressure drop occurs across the orifice. Across means through the orifice. When connected to an engine with zero leakage, there is no air movement and no pressure drop across the orifice. If leakage occurs, airflow occurs and a pressure drop will occur across the orifice. This drop will be reflected in the dial position as leakage or movement towards the yellow or red on the dial. Here are some additional facts about leak-down testing. The Briggs & Stratton tester gauges leakage results as low, moderate, or high. These are arbitrary results and can't be translated to an actual quantity or percentage of leakage. The results can only be compared to the same or similar testers used on similar engines. This is why we are usually more interested in listening to the airflow from the engine than the actual results on the dial. Your analysis of engine health can be improved by performing some baseline testing on known good engines. This can help train your ears as to what is normal airflow past compression components. Though there are variations, the typical size for the orifice in leak-down testers is 40,000ths of an inch. There is no standard for non-aviation use testers, which tells us a lot about the variation in tools and the results they provide. A small leak in an engine with a big bore is a large leak in an engine with a small bore. So some manufacturers supply charts to help interpret results across engine lines. Measuring large leaks in engines is usually less accurate than small leaks, as the faster airflow causes turbulence which skews the reading.